Hello and welcome to GDBS demonstration. This is the second demonstration in a series that I hope that will continue on for time going on in the future. My name is Joe Garrett and I am the founder of VaultSync Solutions. I'm an engineer, I'm not a physicist, and I've been building the system for around 15 years. And I want to say something absolutely up front. This is not artificial intelligence, it's not AI, it's not LLM or any other automated scripting solution. GDBS is actually built upon a system of technology that allows for the client's computing to be utilized in a projected space. There is no neural network, no transformer, no training data, and what you're looking at is a geometric computational engine. It runs real physics on a virtual toroidal mesh. Basically something you project in order to get physics done. And it all does it within your browser. Every result you see has an error rate, and every result is validated against published literature and physics papers. These are real and real benchmarks. And if it is wrong at any of these validation points, it's going to tell you how it's wrong. And there's no hallucination because there's nothing to hallucinate on. It's math in and math out. GDBS stands for Geometric Database System. And so the idea is very simple. What if geometry could do all of the computation instead of shipping your problem to a supercomputer and waiting in a queue, waiting on local run rates? You could do this locally on a browser via a virtual substrate that tracks its own precision. This is exactly what it is. So let me show you. Right now we're currently logged in and we're looking at GDBS Pro's new module, Topology. And as you can see on your screen, there is an already running CODATA parts per million evaluation. And just so we understand that this is running, at the moment we choose to change our data, we can see that each of the tabs at the moment that I click them actually does provide information. Each one of these does just a little bit different from the one before it, and each one validates published physics. And we can see all of the physics specifically, directly, within this particular tab. Right now, this is the chaos tab, and it's a logistic map, in which is the simplest of chaos systems. It's one equation with one parameter. You go ahead and you put in those parameters, and it will give you the bifurcation diagram, period, doubling from state fixed point all the way to the full chaos at r equals 4. The Feigenbaum, you got to understand, I really am no physicist, so I want to make sure that you please understand that I can't. Some of these terms I don't know, and my goal was to build the substrate for these things to run, not necessarily to be able to speak the language. Feigenbaum delta estimate is about 4.660, and the canonical value is 4.6692. That's a universal consent of chaos theory. My substrate is recovering it from a numerical iteration. Lyapunov exponent at r equals 4 is 0.6542. The canonical is ln paren 2 equals 0.691. A positive Lyapunov means chaos. The red line at 0 is your boundary, and above it, chaotic. Below it is stable. And you can see that here. These aren't approximations. These are textbook results. And this isn't happening because I just happen to have drawn the picture on the screen. No, this is an actual physical verification of mathematics running directly inside of the application. So we're going to take a look at the Hopfion. This is a Faddeev-Skyrme Hopfion, a 3D topological soliton that field maps from 3D space to a sphere, and the topology is characterized by this number, which is an invariant of Q and H. Now I am going to go ahead and set the Q and H to a number 2. Now this is a double linked Hopfion, and in doing it, I'm going to change my grid to a 48, and this gives us a 48 cube. And so I'm going to click the button to relax. This is between 320 and 493 milliseconds to run in your browser with no server round trip for the computation. This happened right for you at the moment you click the button. And the math occurs in this computational substrate that I have built through that projection to allow it to execute these advanced physics without a cluster, without a high performance computing substrate, and without any artificial intelligence attempting to give you something. And I know that there's an IEEE 754 limitation that would break the math. And instead of implying that, what I've decided to do is I've given you the drift calculations as an error propagation across this so that you can identify specifically if there's any problems with the output that they are told to you. And if anything is dropped off, you absolutely can trust that the math that comes out of GDBS is absolutely accounting for what would normally be dropped off. So you don't need an error precision rate. You don't need a general order calculation. You literally get the numbers directly from the system. And my goal, of course, is to continue exploring all of the opportunities that this now gives you. Now that I've covered these entire things, I do want you to use it as a system that gives you a delivery of advanced mathematics. It most certainly isn't what we have done in the past. It certainly isn't a high performance computing, and it certainly is a unique differentiation across the application space. GDBS Pro is currently available as a free install for 3 days. You get to test everything inside of it, all of the features, all of the functionality. Every one of these are now available to you at your fingertips directly within a browser. After 3 days, we do have different licensing tiers that you will have to subscribe to. And in those licensing tiers, you get to choose automatically whether you're an academic, a startup, or in standard, plus, or pro, specific pricing per year that will give you direct access to whatever tool you're interested in and whatever regime you're currently working in. Is this an academic tool? Is this a, a business tool or some version in between? Well, obviously with GDBS, we want it to be everything. We will, if you're in an academic study program, if you're becoming a physicist, a chemist, a medical provider, a pharmacology technician, whatever the case may be, we do have academic pricing for you. If your professor is interested in running pre-calculations and verifying information and getting direction without having to go to a HPC scheduling and computing path. Again, we have that availability to you. If you're a startup actually doing some high performance precision computing, etc., but you don't have access to the scheduling or the bandwidth or the ability to pay, we want you to use this program at $7,500 a year. This is dramatically demarked from those systems that cost upwards of a couple $1,000,000 and sometimes between $50,000 each scheduling attempt. And you don't have to wait. Many of them are instantaneous. Some of them are within seconds. Most assuredly, our goal has been to produce and yield results for every single one of these as fast as possible with the highest precision possible. And in any time, if there's any questions about the precision, we definitely provide those. Most of these things are being validated by industry professionals and scientific advisors. We do have our own scientific advisor. We are currently projecting that they are evaluating each of these areas. We do communicate with a multitude of different industry professionals in their particular regime or domain and get their information as a result of this. We will eventually have testimonials on our websites from these very same advisors to identify specifically how they feel about the particular areas without identifying our own wording. Lastly, I do want to thank you for your time, and I do hope that this video gives you information that can decide for you at least to give us a try, walk it through, and see if there's anything that you get answered with this tool that you wouldn't anywhere else. Have a great day. I appreciate you. And again, GDBS Pro available now.